All right, physics sorties, back at it. Here we go. We're on page 52, and we're going to go through some of these problems. It says determine the direction of the magnetic field right of the wire. Okay, so the magnetic field right at this point. Again, left-hand rule, thumb pointing down, called the wire grasp rule, or the first-hand rule for conductors. Of course, it should be into the page. Okay, in this case right here, just turn it over like that, and you can see that it's coming out of the page above it. And so we've got the following. And then the third one, notice this one here is indicating that electrons are coming out of the page, so they're moving in this fashion. Okay. So in that sense, what I do is I wrap my hand around, kind of point your thumb in the direction that those electrons are going, and use your pencil to simulate it. So wrap your hand around like this. Okay. So the magnetic field around the wire would go like this. Okay? So looping around the wire, up, over, and down, the way my hands would, or fingers, sorry, were curling. Okay? Lovely. Question number 2. Although electrons are the only charges that can move in a solid, positive charge is able to move in a liquid or gas. These moving charges can also create a magnetic field. Determine the direction of the compasses around the proton moving into the page. So now we're moving from our left hand to our right hand. Simulate that. You can think about the charge as the same thing as the pencil moving. Now wrap your hand around it, okay? And your right hand, everyone, thumbs down, okay? And so it will line up to go around. So the actual magnetic field looks like this, and in fact it goes in this fashion as well. And so what we'll have is this will be lined up properly so that it lines up with the magnetic field there and here. Determine the direction traveled by the alpha particle below. Okay, so it's a positive charge. I want to have the magnetic field going into the page on the top and out of the page on the bottom. And so it must be going that direction, in on the top and out, curling around on the bottom. So it's moving this direction. Okay. Number 3, determine the nature of the magnetic poles for each solenoid, the direction the compass points. Positive, negative, remember what I said, right? Follow it around, get the direction of the current. Second hand rule for coils coming up here. I like using my left hand for electron current, like this. And so this would be the North Pole, this would be the South Pole, and the compass should point towards the South Pole. Okay, where this is north and this is south. Next one, let's try something different. Okay, what we can do here is we can look at the idea of conventional current, the flow of positive charge. Sometimes that's talked about and introduced. It's really positive charge moving this way. It's called conventional current. So that's the flow of positive charge. And so if we're going to use conventional current, what we're going to use is our right hand. Okay? So using our right hand to show this, what I'm going to do is I'm going to first of all do like I've been doing each time, drawing the direction positive flow is going along this. Okay, and now for my right hand. Notice I'm going to wrap it around like this, showing that this should be north, this should be south, and therefore it should curl around like this. Okay? And the compass will line up. Well, this is north and this is south. Okay. Now we could also do the other direction, and what I'd notice here is I have the same outcome. The electrons would come around and they go the other direction here along there. And so what I do is I'd use my left hand rule. Okay, same result though. All right, number 4, determine the nature of the magnetic poles for each solenoid and the direction of the electron flow around the solenoids. Okay, so if the compass is pointing this way, then we must have the north pole of the compass coming towards the south pole of the electromagnet and then looping around, making this south and this north. Now what we can do is we can use that same hand rule for coils, and we can figure out the direction that it must be going. So if I want to use my left hand, for example, then I know that it's going to be pointing towards the north here. My hand's going to wrap around, so knowing that the current has to go up on all of these branches. Okay? And that means that the current's going this way and coming from this way. Making, of course, this one here be the negative pole and this be the positive pole of the battery. Same sort of thing here. I know that this is going to be a south pole, this is going to be a north pole. I'm going to now use my left hand, just wrap it around, okay, pointing north, and then I know that my fingers are curling around, showing the current is going to go this direction on top of the core there. Now in that case, it must be going this way and coming in at X and exiting at Y. Okay. Again, just to make sure we're clear, this of course would be the negative pole. Electrons are moving this direction from here, so that means that this would be negative. And electrons are going this direction here, making this positive. Okay. All right, we're going to take a little break, then I'll do the next